While we're on the topic of air pollution, we can't neglect another related topic, which is acid rain, because acid rain is a phenomenon that is ultimately caused by air pollution. Acid rain is precipitation that has a pH below 5.6. Remember, pH anything below pH 7 is acidic. So normally rain is slightly acidic. Normally rain has a pH of about 5.6 because water droplets in the atmosphere will dissolve some amount of carbon dioxide gas and it will turn into carbonic acid in those water droplets. So rain with a pH of about 5.6 is normal and not a problem. But when other airborne compounds react with water in the atmosphere and generate acidic products, then the pH of the water droplets can go much lower than 5.6, dangerously low to the point where the precipitation is harmful to living organisms and the environment. And this can occur due to both natural sources of pollutants like volcanic eruptions or man made sources such as emissions that are brought about by burning fossil fuels. In the realm of man made pollutants, the primary culprits for acid rain are sulfur dioxide and nitrogen oxides, which are two of the criteria pollutants that we talked about previously. And when these interact with water vapor in the atmosphere, they form sulfuric acid, which is H2SO4. You can see that in the illustration at the right, and nitric acid, which is HNO3. And both of these lower the pH of rainfall considerably, and that can lead to a variety of harmful consequences. So, firstly, when acid rain infiltrates soil, it changes the soil chemistry. It causes nutrients like calcium, magnesium, and potassium to leach out of the soil. And you may remember from our soils chapter that all of these are essential nutrients for plants to grow and survive. So this is a threat to plant life. Additionally, when that acid rain infiltrates the soil, it causes mineral particles to release toxic substances like aluminum, which can then enter runoff and be carried to rivers and lakes and also be taken up by plants. The trees that you see in the upper photo have all been affected by acid rain, and it's believed that it's a combination of the loss of essential nutrients, the leaching out of nutrients, combined with the increase in toxic substances like aluminum, that those two factors together are responsible for the effect that acid rain has on killing plants. In the human realm, acid rain also damages infrastructure. It can damage paint and coatings, it can corrode metals, and cause deterioration of stone, which is what you can see has happened in the lower picture. And thankfully, acid rain has improved in the US over time. You may remember seeing these images side by side in a previous chapter. The left shows the incidence of acid rain in the US between 1989 and 1991, and then the right shows acid rain from 2019 to 2021. So previously, acid rain was very prevalent in areas of the country where there was a lot of industrial manufacturing and coal fired power plants. But in 1995, the EPA added an amendment to a piece of legislation called the Clean Air Act that restricted emissions of pollutants from power plants. And it resulted in a significant decline in the incidence of acid rain, as you can see. So, this transitions us nicely into our final topic of the chapter, and that is air pollution legislation. So, in the United States, the primary piece of legislation regulating air pollution is the Clean Air Act. So, the Clean Air Act was originally passed in 1963, but this version was not a very comprehensive effort. It basically established a program for research into methods of monitoring and controlling air pollution. In 1970, the Act was amended in a way that made it much stronger. So the 1970 version of the Act authorized the Environmental Protection Agency to develop actual regulations that would limit the amount of pollution being emitted from both stationary and mobile sources. The priorities of the Clean Air Act have been to reduce air pollutants that cause smog, haze, acid rain, and other environmental problems, to reduce toxic pollutants, which remember are ones that are known or suspected to cause human health problems, and of course, phasing out the use of ozone depleting chemicals. And as with many pieces of environmental legislation, in order to pursue these goals, the EPA has to partner with state, local, and tribal governments to ensure that air quality standards are being maintained in all areas of the country. And so states have to submit what are called state implementation plans or SIPs to the EPA showing how they're going to meet the air quality standards set out by the Clean Air Act. And then the EPA is responsible for assessing and approving those plans. And the standards for pollution and air quality that are established in the Clean Air Act are considered the minimum that states must do to control their air pollution. They can choose to establish stricter regulations that require even lower levels of pollution, but they can't establish looser regulations than what the Clean Air Act lays out. If a state or municipality isn't meeting the standards for pollution and air quality, then the EPA is authorized to sanction that state or even take over enforcement of the Clean Air Act regulations in that area. Overall, the Clean Air Act has had a profound positive impact on air quality in the US. It has led to a very significant drop in the total level of emissions of these 6 criteria pollutants, even as the country's population and GDP has continued to grow. So, what you see in the graph on the right is several metrics pertaining to the US. The light blue line at the top is gross domestic product. The orange one below it is vehicle miles traveled. The dark blue is the US population. The red is energy consumption, and the lime green one is CO2 emissions. And then the dark green one at the bottom is the total emissions of the 6 criteria pollutants. So the point is, looking at this graph, that even as these other metrics have continued to go up or remain steady, these 6 criteria pollutants have dropped. Specifically, they fell by 59% between 1990 and 2010. So this means that the country has been held to stricter standards under the Clean Air Act, under terms of, in the sense of how clean our technology has to be, how clean vehicles have to be, how clean power plants have to be. And that has had a huge positive effect on air quality. Other data points that show the impact of the Clean Air Act include the fact that in 1991, there were 41 different areas of the country that were shown to have unhealthy levels of carbon monoxide. And now all 41 of those areas have been able to clean things up, and today they're all within the limits of what's considered safe carbon monoxide exposure. Also, airborne lead pollution, as we discussed previously, has dropped by 95% thanks to the phasing out of leaded gasoline. And of course, acid rain incidence has dropped by 68%. So all in all, the Clean Air Act has been enormously positive for air quality in the US. Air quality still isn't perfect. Many metropolitan areas still have a big problem with smog and ozone, but this piece of legislation is a good example of how regulations can better human health and the environment.